It was a little over 20 years ago when Bill Gates, then still at Microsoft, sent out a famous memo called the Trustworthy Computing Memo. In a nutshell, he said, hey, our software needs to be secure. That needs to be a priority. I know that sounds ridiculous and obvious by today's standards, but when you're struggling to get products to market, it's easy to overlook the way people might use those products in a negative and perhaps unforeseen way. Those lessons have largely been incorporated into software engineering, and I think a similar process is happening where data-driven products have started to focus more on what probably should have been obvious, or just as obvious as secure software, that we need privacy protection in our data. But we don't want the same standard knee-jerk IT reaction of lock everything down and don't do anything. Companies do need to interface about private data. Companies need to conduct business while also keeping their customer data secure. This is absolutely true in the world of ad tech, where your information is constantly being shared to better target you, sometimes for good, sometimes for evil. And an important type of tool for those sorts of exchanges are the topic of today's interview. We're talking about data clean rooms. And if you've never heard of that before, that's okay. We're going to get into it from the basics all the way up to how to deploy this into production.
My name is Bosko Milekic. I am the Chief Product Officer and co-founder at Optable.
Well, tell us a little bit about what Optable does.
Sure. So Optable is a data collaboration platform for the media and advertising industry. And what we do is we basically enable both advertisers and publishers to collaborate on the basis of their first-party data. So when I say first-party data, I'm talking about user data. We enable these collaborations to happen using clean rooms.
I know what a clean room is in sort of the medical sense, but what does it mean in the data science world?
Sure. So I think you have listeners who understand data, and so let me try to describe it kind of bottom up. That's how I like to think about it. So imagine you have two organizations. They each have data sets that describe users, and they're interested in joining these data sets for some purpose. Maybe the simplest possible example could be that they want to do an intersection between their data sets and understand, let's say, the size of the intersection. Historically, the way that this might be done is that they might agree through, let's say, a contract. Let's do this together. And then typically, like, one of the organizations would give the other one access to their data set. And then the second org would take that data and combine it with theirs, do the computations, and provide the answer. So clean rooms are a way to do this kind of combining of data sets and computing also on the combined data sets in a way that enables the organizations to control the amount of information exchanged between each other pertaining to the data. And one way you can think about how that works is, instead of, if we're two organizations, instead of one of us sharing our data with the other, we would both agree to the computation using some form of infrastructure. Let's just call it clean room infrastructure. That computation would then be this immutable thing that we would both be able to share our data sets with. It would run on these shared data sets, produce the outputs, and then make them available to either one or both of us, depending on what we've agreed to in code. So it's a way to do basically collaboration through software and code, in addition to just having business contracts to govern how it's done.
So I have, for example, an email list, and we send them out stuff about the show every so often, and once in a while there's an ad in there. We haven't gone too deep on that, but I'm aware that this is an area where techniques like this get applied a lot. I'm certainly not going to give my mailing list away to anybody because I don't want, that list to fall into some spammers' hands and annoy the listeners. But, if there's somebody who wants to say, ask me a question like, how many of our mailing list members line up with yours? Because maybe there's some promotion we're going to run, something like that. We want to get that answer, but they don't want to give me their list. I don't want to give them mine. Is that the right problem set?
That's exactly right. Yeah.
So what exactly do we, right. I mean, historically, I think we would have just kind of had to reinvent the wheel or come up with some plan. What are sort of best practices for solving a problem like that?
Right. So we both, would have to agree on where we're going to do this matching. And we would have to have a way to independently verify that, the matching that is being done and the computation that's being done on the match is what we've agreed to. And so we could both take our data sets to a clean room vendor, then using that clean room vendor, define the operation that we want to do. And then that clean room vendor would provide us the guarantee that the operation is immutable throughout the duration of the computation, that it only has access to the data that we've shared with it, and so on and so forth. There are different types of clean room vendors, and there's also obviously the question, like, what does the clean room vendor see? Like, what do we have to trust the vendor with? Like, do
Yeah.
they have to see our data? Do they not have to see our data? There's also an emerging set of technologies that could enable us to do this kind of computation, depending on what it is, that could enable us to do it in maybe even a peer-to-peer way using a protocol that works on encrypted data. And so I think one of your guests a few weeks ago was talking about secure multi-party compute, or maybe I'm remembering wrong, but in any case, secure multi-party compute is one such technology that could allow us to combine our data sets, potentially even directly with one another, without it ever being decrypted.
So I appreciate that you describe it as a computation we're going to agree on because that's robust. We can do, all types of things in this scenario. I'm wondering if you wouldn't mind unpacking that a little bit, maybe some examples of what are common computations two parties want to engage in.
In media and advertising, we think of the use cases broadly as spanning the problems of planning ad campaigns, measuring them, also activating them, so targeting overlaps, for example, or users that are derived from overlaps. Let me give you some examples. Let's take the case that you talked about, where you have a list of users, you have maybe email addresses, and I have the same. And let's say that you have some attributes on those users, and I have some attributes on my users. And so what we're interested in doing to plan a campaign, let's say you're the advertiser and I'm the publisher, is we want to do an overlap of our user bases. We want to be able to understand for that overlap, like, what is the distribution of the users in terms of the various attributes that we have. That output could be completely aggregated output, right? You don't need to know, which individual user has which individual attribute. You just need to kind of know the count of users in the overlap grouped by the various attributes. That is an example of an analytical application that we could agree to ahead of time and then define within a clean room environment, and then expose our data sets to. And then that application would run on those data sets and produce those distributions in aggregate. In some cases, we might want additional protections. Like, we might, want it to make it very difficult, for example, for one another to learn which individual users are in that overlap. And sometimes, if you have a lot of attributes and you get a lot of analytics out of these operations, one of us may be able to triangulate, right, and figure out like which individual user is in the overlap. So there are various techniques that can be used to prevent that from happening. For example, you could add statistical noise, you could round threshold, differential privacy would allow you to further limit how many times you allow this type of intersection to run, this kind of computation to run on the same data set, and so on and so forth.
Having a third party is a nice part of this because, even though, as you point out, I have to trust the third party, there's not a lot of motivation to be the man in the middle. So if I give you my email list and some future partner gives you their email list, and we trust that at the end you're going to throw the two lists in the trash when the compute is done, it seems pretty secure. Do people tend to take other steps as well? Like maybe we should hash the emails before we send those, and then you compute on this hashed value. Is that a common practice?
Yeah, I would say that's a very common practice. In addition to that, there are clean room environments that could also operate on encrypted data. And there's different variants of these. So, for example, there are clean room environments where that run within secure enclaves. So these are hardware-based security mechanisms that enable the collaborating parties to, for example, encrypt their data with a key that comes from an enclave, such that the enclave operator can't actually access the key. And so in that case, the data actually when it goes into the clean room environment, it goes in encrypted and remains encrypted except when it's within this enclave environment, which actually even the operator cannot get access to. Then, there are clean room environments that are supported by secure multi-party compute techniques, where in a similar way, each party could encrypt their data with their own keys and then execute a protocol that enables one of the parties or both of the parties to compare the records without decrypting them. And these techniques tend to leverage cryptographic properties that enable, for example, comparison of data or computation on encrypted data without decrypting it.
Is that like, I think I've heard the term homomorphic encryption as being kind of a research area. I haven't heard a lot about commercial applications. Is this something you're taking to market?
So homomorphic encryption is a good example. There are other techniques in cryptography that have similar properties that allow you to, for example, like you could encrypt your data with one key, I could encrypt my data with another. We could swap the records. You can then encrypt my data a second time with your key, and I could do the same with yours with my key. And even though they've been encrypted in different orders, because of the type of encryption used, they could still remain comparable. So meaning that two values will encrypt to the same value, even though the order of the encryption is reversed. Doesn't necessarily mean that you're using a homomorphic encryption, a fully homomorphic encryption scheme, but you're using an encryption scheme that has that property.
Hmm.
To your question as to whether we're taking that to market, yeah, we do use some of these techniques to enable, for example, one of our customers to match with someone who's not our customer using a secure MPC protocol to enable the matching, where the non-customer is able to independently of us encrypt their data with their own key and exchange it with our customer in a way where we can't decrypt it.
The merging of the two email lists, or finding the intersection or whatever it may be, seems like a strong problem in my mind that I would use a clean room for. But it also is like a batch problem. It feels like something we're going to do once. Is that a typical approach, or are there sort of real-time transactional ways to use clean rooms?
Yeah, good question. So, from what we've seen, it often is a batch type approach, but it can be repeated, right? And so, if you are, for example, executing an ad campaign and it's running over a period of time, the underlying user data might be evolving throughout that period. And so, you might want to reperform this match periodically. And ideally, you have all of that automated. The match itself tends to be performed in kind of a batch fashion, but it can be repeated.
And could you maybe share another example or two? The email one's a prominent one, but I'm sure there's more sophisticated things being done. Is there anyone maybe pushing the limits of the platform in interesting ways?
Well, we're starting to see applications involving modeling. So where
Mm.
the computation that actually happens is you're doing an overlap, but then the output is not the overlap itself, but it's, for example, a list of users that has been scored by a machine learning model that was evaluated using data from the overlap. Right. So in that case, imagine a scenario where you have one party that has a large list of users, and only a subset of those users actually identified via email, for example. And you might be an advertiser, and then we'll do a match. If I'm that party with the large unidentified user base, what I'm interested in actually doing is using the list of overlapping users to then train a model that will score all of my other users in terms of how similar they are to the overlap. That's a type of computation that is also conducive to clean rooms, in particular because if using various techniques, you can actually I might actually be able to guarantee to you that I won't even learn the identity of the users in the actual overlap. Like all I will learn is the scored kind of output of the model running on all of my other users, and there might be additional protections baked into the computation that actually make it very difficult for me to reverse engineer who was in the overlap.
Thanks to our sponsor, Neptune.ai. 99% of machine learning teams are doing awesome things at a reasonable scale with 4 people and 2 production models. But most of the industry best practices come from a handful of companies operating models at hyperscale. The folks over at Neptune.ai want to change that by sharing insights, tool stacks, and real-life stories from practitioners doing machine learning and ML ops at a reasonable scale. They even built a flexible tool for experiment tracking and model registry that will fit with your workflow at no scale, reasonable scale, and beyond. Check them out at Neptune.ai. You use the word guarantee, which is a well-chosen word often by an engineer. I'm curious, is that a guarantee that you make by having a sound business that follows good principles and says we're definitely not going to do this and we have checks and balances, or is it a cryptographic guarantee?
The short answer is it's a bit of both. And you can have strong mathematical guarantees, like for example, guarantees provided by the differential privacy framework that you're going to have privacy preservation in a particular computation that you're doing, involving two data sets derived from users. At the end of the day, those guarantees depend on the organizations that are collaborating at some point stopping the computation, right? So if they can just infinitely repeat the computation over and over again on the same user data, it's very difficult for differential privacy guarantees to hold.
Hmm.
And so, generally, you need a combination of technology and policy to offer strong protections when it comes to collaboration on user data. The other thing I'll say is there are now mechanisms, emerging mechanisms in, like, for example, browsers that do offer very strong mathematical guarantees on privacy. And those are possible because the user agent itself is involved in limiting the amount of information that actually leaves the user's device or browser. When it comes to data collaboration between two entities that have already collected user data and are able to identify users, it's a little bit of a different setup. And in my experience, you need a combination of strong policy and technology to help guarantee privacy preservation.
So, from a programmer's point of view, how do I get data in and out of the clean room?
So it really depends on the clean room. Some data warehouse solutions have started to offer clean room capabilities. In those instances, getting data in and out of the clean room is basically a matter of getting data in and out of the warehouse and then configuring the warehouse, jointly with your partners to execute these kind of shared applications on data sets. In other cases, you have APIs. So in the case of Optable, for example, we offer APIs as well as a bunch of connectors to existing and popular marketing systems that allow you to just basically through a few clicks connect your data and bring it into the clean room environment.
These are problems that aren't new. I remember one of my first jobs, I was on a team that we built some hacky homegrown way of matching lists in a semi private way. But I definitely see the need for tools like this in the market. What has adoption and growth been like?
So, a lot of media owners and advertisers have realized that open identity, like through third party cookies, for example, is going away.
Hmm.
And it's not a question of if, but more when. As you probably know, there have been some delays in, for example, Google Chrome deprecating third party cookies. But I would say at this point, there's very little doubt that it's going to happen. So we've seen quite good adoption. I would say it's still early days in the sense that there's the sense of urgency for everyone is not maybe yet apparent to move off like open identity systems that enable pervasive tracking of users on the internet to these mechanisms that require direct collaboration between advertisers and publishers using technologies like clean rooms, but it's certainly accelerating. This year we've seen a huge acceleration in adoption, and we expect that to continue into the new year.
Well, it's probably never a good idea to group all people into two buckets, but if I had to do that in terms of privacy, I would say there are people who don't think about it and people who are very concerned and don't want to be tracked anywhere. And I can understand that to some degree. I've bought flowers and seen flowers ads for 6 months afterwards and found that a bit annoying. Is there a pro-consumer side to this, that a data clean room and the exchange of anonymous data between maybe a publisher and an advertiser can improve my experience without compromising my privacy?
Absolutely. And I think that's, I talked about early adopters a moment ago. Certainly on the advertiser side, I think many advertisers and brands have realized that. And consumer opinion has effectively already shifted. People have come to realize how their data is used and kind of some of the side effects that result in this tracking of users across the internet. And so, because of that, advertisers are recognizing that shift, and it's actually helping with adoption of technologies like ours. And I think that at the end of the day, that's a good thing for end users. I see a future where privacy is on by default, right? It's not an
Hmm.
afterthought, but it's there by default. That is a future that we're building toward.
What's the life cycle of a project like from the moment someone says, let's do this until they have some actionable data?
Typically, it's pretty quick for us in the sense that you can connect existing user data that you have sitting in your, let's say, customer data platform or data management platform fairly seamlessly. Where we have seen barriers to adoption is around this problem that if you have two parties that want to collaborate on the basis of first party data, they often have to be using the same clean room vendor, the same clean room infrastructure. And that can sometimes be an impediment and kind of a source of friction when it comes to collaboration. So that's a problem that we've been very focused on at Optable. We have been building interoperability with other types of clean room infrastructures. For example, if you're a publisher and you're using our system, you could connect your data into our system. But then if you have a partner that maybe has their data sitting in Snowflake already, you could just invite them to collaborate through Snowflake and we automate the process for you. The actual trust in that instance is provided by Snowflake itself. And we have similar methods like with other types of infrastructure. So I mentioned earlier, secure multi-party compute. That is another way that one of your partners can, for example, execute a match with you. In that case, the partner can actually use their data wherever it's sitting with some tools that we make available for free that are open source. They're able to independently verify that their data is being matched while it remains encrypted. They don't have to become our customer, and collaboration can still happen. In a nutshell, it's easy when both parties are using the same system. It's a little bit more difficult when you have parties using different systems. And so that's why we think this interoperability is it's a really important capability to make this stuff easier to adopt in the future.
Well, let's imagine two giant behemoth companies that want to do some project together, and there's two engineers on each end. They're both on Snowflake, lots of data there. So I guess the technology setup's right. They're going to do this all secure. I'm aware that some of those technologies, like homomorphic encryption and whatnot, you pay a cost, a computational cost for it, because obviously there's more to do than just a basic unencrypted version of it. Should those engineers be planning around that? Is there going to be a time issue to worry about, or I guess what are some of the challenges they'll face along the way?
Yeah, so not all types of clean room infrastructures require the use of homomorphically encrypted data to enable collaboration. I mean, you mentioned Snowflake. I think that's a good example. Like in Snowflake, the actual guarantees that the other party doesn't see your data are provided by various primitives within Snowflake that don't require the data to actually be encrypted explicitly by the parties. So it makes the collaboration in some sense for the programmer a bit simpler, but it does require both sides to trust those primitives. They can verify them independently of one another. They're operating each with their data sitting in their own Snowflake accounts, but the trust itself is provided by the primitives and by Snowflake in that instance.
So I could see a case where maybe an advertiser would come to me and say, "We're not sure if Data Skeptic is technical. We think it's children listening to this who don't have education. It's not the data scientists you say who listen. Prove it to us." This could be a tool to do that. That's the publisher coming to me. The other way would be me pushing to the or I'm the publisher. Me going to the advertiser saying, "Look at this anonymous data I've created that tells you a little bit about my audience." Do you see which way does that conversation usually start?
So we've seen both. In our experience, we're seeing quite a bit of success with publishers providing sort of bring your own data offerings to advertisers that utilize clean rooms to execute the actual offering. The idea being that, if you're a publisher, for example, you have a list of identified users, you understand when those users are listening to your show, and you offer the ability for an advertiser to bring their list of customers to you and kind of match those against your audience and find those users You might also give them the ability to learn insights about those users that they didn't know about otherwise, but that you uniquely have. In that scenario, like you don't want all of these advertisers sending you email lists, right? So it's kind of a
Mhm.
perfect use case for clean rooms, and that's a scenario that we've seen quite a bit of traction around. There are examples from retail media also that we're seeing some success with, where you have a retail media company that has data about what users buy and creates a relationship with a media owner or publisher whereby they can enable a CPG advertiser, for example, to leverage the retail media company's data in order to build an audience and then find that audience on a third party publisher environment. And that all is enabled through clean room matching and clean room processes.
So Optable is a platform. I'm curious if you could expand on maybe its current state and future state. You could be a success as just like a utility technology where people come in, they do this operation and they walk away. Or maybe there's going to be layers of services that you help me with that machine learning situation you described, or you kind of offer me these higher level services in addition to all the connectors. I guess what's the current state of the platform and where do you see it going?
We see ourselves as a data collaboration platform and not a clean room in and of itself. I talked about earlier how we interoperate with different types of clean room infrastructure. Our goal really is to make it easy for publishers to serve and deliver what we call clean room media. These are media products that are rooted in collaboration. The simplest version of a clean room media product is, for example, the retargeting product. Like I have a list, you have a list, I want to find those users. But there are many other examples, and what we are focused on is really making all of them really, really easy to execute, both for marketers and for media owners. You're right to say that Optable is a platform. We are focused, if you will, on that kind of application layer for media and advertising that is powered underneath the hood by various types of clean room infrastructures. Where we're going with this is making these applications as interoperable as we can with all of the clean room infrastructures out there, and there are many that are emerging as well. Our goal is ultimately to remove friction from the process of collaboration, and that's what we're super focused on.
I know you may not have visibility into this, but I'm curious, do you have any insight into how people evaluate the output? When it comes time to say, was this a good experience? What's the metric that says it was a good project with Optable?
It's actually very simple, and I don't think this is unique to Optable. I think in general with clean rooms these days, we're hearing a lot about them, right? There's like a lot of buzz around clean rooms and clean room technology, especially this year because of the promises that they provide. But at the end of the day, like the key metric is ROI. Really, it's how can I use this technology as a media owner to deliver media products that are useful to brands, that protect the privacy of users, and that have scale. Conversely, for the brand, are worth buying, right? Because they solve a particular problem for that brand. Either they help them reach their customers or loyalty members, or they help them prospect better, or they help them plan campaigns better or measure and understand their ROI better. So these are real problems in media advertising. They're not new problems. They've existed for a long, long time. Historically, they were solved by systems that were built on top of open and widespread identity sharing in the form of third-party cookies and mobile ad IDs and things of this sort. And we're rebuilding these mechanisms on top of data collaboration and clean room systems, right, that involve companies collaborating directly with one another. The main metric really is return on the investment.
I'm reminded of when retargeting hit the internet, as a technique, and obviously to a lot of success. A lot of companies got benefit out of retargeting, still do, but it also created this slight level of creepiness where ads follow us around, and we can joke about that. So the experience of the internet changed with that technology coming out, and I feel like clean rooms are also an emerging technology, a more contemporary one. Do you think the average person is going to recognize a shift in their internet experience, or will this be a more subtle change?
I think that, I hope anyway, that end users will recognize a shift. One of the problems actually with third party cookies and third party cookie based methods, for example, doing retargeting, is that oftentimes as an advertiser, when you do those kinds of executions, you don't even know where the ad is running, right? Like you could be retargeting users, you don't know where it's running, you don't know how many times it's running. Sometimes you're able to control that, other times you're not. And so, like the end user's experience is that they might start to get followed, like they're followed around with these messages everywhere they go, even in places where they wouldn't expect to see them. The fact that something happens that you don't expect, that is a big problem for the end user, and it actually turns out it's also not very good for the advertiser. One of the things that's great about data collaboration is that it tends to be like, if you're an advertiser, you're collaborating with media owners, you know who they are, right? And so you're picking and choosing them. And so there's this kind of inherent like traceability that's built into the process, wasn't necessarily there by default. These third party cookie mechanisms where you're able to, as an advertiser, use data decoupled from the media where it's running.
For listeners who want to learn more, where should they go on the internet?
Sure. So you can check us out at optable.co. You're also welcome to email me, just Bosko, Bosko, at optable.co, and I'd be happy to talk to you.
Cool. We'll have some links in the show notes for listeners to follow up. Thank you so much for taking the time to come on and share your work.
Thanks for the opportunity.
That concludes this episode of Data Skeptic Ad Tech. Here's a quick preview of what I got in store for you next time.
Ad fraud is an umbrella term that covers a lot of different things. At its core is somebody taking actions to defraud somebody else in the ad space. And what placement laundering is about, and that's what our paper is about, is people claiming that they're going to display a digital ad on one site. They're actually paying out and displaying it on kind of a lower quality site. So that lying, that violation of trust is where the fraud is occurring.
That's next time on Data Skeptic Ad Tech.